everyone, we are going to learn about nitranes. Nitranes are neutral monovalence, highly reactive reaction intermediate containing one single bond and two pairs of electrons on the nitrogen atoms. Nitranes are the nitrogen analogues of carbons. Nitranes also known as imines. For examples, this is the simplest nitrene. The simplest nitrene is called iminogen. Other some nitranes are, these are alkene nitrene, these are aryl nitrene, these are acyl nitrene, etc. Nitranes are short-lived and highly reactive intermediates because in nitranes, the nitrogen atoms only 6 electrons in the outermost shell, so it has a tendency to complete the octet. Nitranes also behaves as electrophile as well as it behaves as Lewis acid. Now I am going to discuss about the formation of nitranes or generation of nitranes. Formation of nitranes. Nitranes are formed from number 1 from azides. This is a one resonating structures of azides. Thermal or photochemical decomposition of azides gives nitrene. Similarly, thermal or photochemical decomposition of azides comes similarly from alkyl isocyanate. From alkyl isocyanate, this is alkyl isocyanate. This is alkyl isocyanate. Thermal or photochemical decomposition of alkyl isocyanate gives nitrene. There are so many methods for the formation of nitranes, but these two methods are very important for the formation of nitranes. Now, the structures of nitranes. The structures of nitranes. There are two structures of nitrene. One is called singlet nitrene and another is called triplet nitrene. In singlet nitrene, the 4 non-bonded electrons on the nitrogen atom in the forms of 2 lone pairs of electrons and it is in the sp2 hybridized state. For example, this is singlet nitrene and it is in the sp2 hybridized state. 2 lone pairs of electrons in the sp2 hybrid orbital and this is the p orbital. So it is singlet nitrene and it is in the singlet nitrene and it is in the sp2 hybridized state. In triplet nitrene, it is in the sp2 hybridized state. In triplet nitrene, the 4 non-bonded electrons on the nitrogen atom is in the form of 1 lone pairs electron on the nitrogen atom in sp hybrid orbital and 2 unpaired electron in the 2 different orbitals and it is in the sp state. So this is the two structures of nitrene. One is singlet nitrene and the another is triplet nitrene. Then stability of nitrene. The triplet nitrene is more stable than singlet nitrene because in triplet nitrene the unpaired electrons are in the 2 defined orbitals. So electron repulsion is minimum. So triplet nitrene is more stable than singlet nitrene. Then reactions of nitrene. Nitrene shows different types of reaction. Number 1, addition reaction. Number 2, insertion reaction. Number 3, rearrangement reaction. And number 4, dimerization reaction. These are different reactions shown by nitrene. First, I am going to discuss about the addition reactions of nitrene. Nitrene when react with alkene, nitrene reacts with alkene. This nitrene reacts with alkene, give aziridine. This is an addition compound. It is called aziridine. Addition reactions of nitrene will give a cyclic compound. It's called aziridine. Number 2, insertion reaction. For example, this is a nitrene. This is a nitrene. In this nitrene, through nitrogen hydrogen sigma bond formation, we get this compound by insertion of nitrogen hydrogen sigma bond. Similarly, nitrene, another acyl nitrene, this on inserted through the formation of nitrogen hydrogen sigma bond gives a product, give this product. So these are the two examples of insertion reactions shown by nitrene. Then the third one is the rearrangement reaction. This is the most important reactions shown by nitrene. Generally, rearrangement reactions is shown by nitrene. For example, say it is acyl nitrene. It is acyl nitrene. Acyl nitrene on rearrangement, we get alkyl isocyanate. And this reaction is very important because on hydrolysis we get a compound. We get a compound, a very unstable acid. This is called carbonic acid. Slightly heat this acid with the elimination of carbon dioxide, we get primary amine. And this reaction, the nitrene formation reaction generally occurs in the formation of primary amine. Say, for example, in the formation of primary amine, Hoffman degradation reaction, Cartier's rearrangement, Lucerne rearrangement, and Beckman rearrangement, all these reactions occurs through the nitrene formation. For example, in the Hoffman degradation reactions, what happened? It is a primary amine. It reacts with bromine in presence of alkaline medium, strong alkali solution. We get a primary amine with the elimination of sodium bromide plus sodium carbonate and the water. This reaction occurs through nitrene formation. How this reaction will occur? It reacts with bromine. Firstly, it reacts with bromine. Firstly, it gives a N-bromoamine. It reacts with sodium in alkaline medium. It takes the proton. We get a compound. After elimination of bromine, we get the nitrene. This nitrene. And this nitrene on hydrolysis, on rearrangement, we get alkyl isocyanate. And from this isocyanate we get the hydrolysis, and heating we get the primary amine. So this reaction is called Hoffman degradation reaction. In this reaction, what happens? Nitrene is formed as intermediate. Like Cartier's rearrangement, unlike Hoffman rearrangement, Cartier's rearrangement is also acyl azide. On heating, with loss of molecules of nitrogen, we get acyl azide, alkyl isocyanate. And this isocyanate on rearrangement, we get acyl azide on rearrangement, we get isocyanate, and these on hydrolysis and heat, we get the primary amine. So in this reaction, this is the reaction is called Cartesian rearrangement, in where from SiNZ we get the primary amine. In this reaction also an nitrine is formed as intermediate. Likewise in the split rearrangement, from where carboxylic acid react with hydroxylic acid, carboxylic acid react with hydroxylic acid, carboxylic acid react with hydroxylic acid in presence of concentrated sulfuric acid, we get primary amine. This reaction is also occurs through the nitrine formation. Similarly, Lucerne rearrangement, it also occurs through the nitrine formation. These are the different reactions through which nitrine is formed as intermediate. So, rearrangement reaction is the most important reaction for nitrine intermediate, for the formation of nitrine intermediate. Lastly, dimerization reaction. Nitrine on dimerization, 2 moles of nitrine, alkyl nitrine on dimerase give diamine. It is diamine is formed. Similarly, aryl nitrine, 2 moles of aryl nitrine on dimerase, 2 moles of aryl nitrine on dimerase, we get azoarine. We get it is azoarine. So these are the examples of dimerization reaction. So these are the different reaction: addition reaction, insertion reaction, rearrangement reaction, and dimerization reaction, generally shown by nitrine. Then detection of nitrine. Nitrine is detected by trapping with carbon monoxide or alkene. Nitrine when trapped with carbon monoxide, we get alkyl isocyanate. Similarly, nitrine when react with an alkene, it forms an acyclic compound called aziridine. So from this reaction, nitrine is detected. Nitrine is also detected by the UV and the IR spectroscopy. Generally detected by UV spectroscopy, and observation maximum is found to be 300, lambda max is found to be 336 nanometer. So in this class I discuss about the formation, how nitrine is formed, then the structures of nitrine, then the stability of the nitrine, reactions of nitrine, and how nitrine is detected. So I hope you all understand it. Thank you. 10 minutes lagena.